Okay, now what this demonstration is going to show is to exemplify what Garland Robinette has shown on all these other tapes that he's already done, you know, back in the 80s, and all the scientists have endorsed it, and that was on a real primitive model I built of the technology. This is a production model showing this will run the world. Now we're going to take and hook to AA batteries. These batteries right here is a AA battery. Now to show you that this thing has no current ability, if you take a 1 ohm resistor right here, this 1 ohm resistor, you can buy this from Radio Shack. You can buy a 1 ohm resistor. You can buy this little holder right here that holds the battery. And if you hook it to this resistor, it will kill that battery the instant you hook it up. It'll fall from 1.6 volts to 1.2 volts the instant you touch it. That's 25% drop. A battery is considered dead when it falls 10%. All right, now we're going to pick up where we're talking about that you can get this from several places, but you know, you can buy that resistor, you can buy this little old battery, and you can make this demonstration for yourself. We got it all hooked up. All I got to do is hook this wire right here to this, and it's got a circuit. And this battery voltage, now Jim's going to show up to that voltage. Put your voltmeter on. You can see that we have 1.62 volts. 1.62 volts. Now I want y'all to notice something. You're not supposed to pull much current from this battery because look at the size of this little wire. It's the size of a thread. This little wire is tiny compared to this small wire on that resistor. This wire is the size of a thread. So you know you can't pull much current to it. You'd burn that wire in two. Now watch the voltage fall the very instant I hook that to it. There's 1.3 already. And that's a good 20% drop. No, in that system. That battery is dead. 10% drop. The battery is dead. The instant you hook it to it, that is a dead battery. Now I want to show that this motor's running. Now what we're going to do is run this motor, and you're going to see it draw positive current just like you would expect it to. The motor's running, you can hear it.
3 amps.
No load on it. No load on it. You don't see no negative sign on that, and you won't see one. We can sit here and we'll run this battery totally down, and you'll never see a negative sign. That's true on any of these motors, anywhere that you buy, except on the motors that I build. The people of the world should be behind it. Now, just like this little conventional motor here, it draws 10 amps under load to a 12-volt battery. That's 120 watts of power. This little motor here wouldn't begin to turn the shaft of this machine that has a rotor in it that weighs right at 1,750 pounds. Now we're going to have a 375-pound mud pump hooked to this motor shaft that takes 10 horsepower to run that particular pump. Now we're going to run it off of these batteries in series. We got close to 400 volts. The current's equivalent to what's in one little battery. One. That's the current capacity. Now you multiply the voltage capacity by putting them all in series. The current capacity is that of one battery. We know on a 1 ohm resistor, it'll pull 1.5 amps from that. It'll kill it the instant you hook it to it. This little motor, like I said, draws 10 amps. It wouldn't begin to even turn that motor over there. This motor from Granger draws 219 amps. So what should this motor draw? The conventional people, even my patent attorney, Emmett Pugh, when I first built that prototype that Garland had covered, I pointed to a pine tree. I said, Emmett, you see that pine tree? He said, yeah. I said, if I took a magnet that big and put material around it proportionally the way I build these motors, I said, it'd have so much power it could pick up your car and shake it like a dog shaking a rag. He said, good God, Joe, I'm trying to help you. And you make those kind of statements, it blows my mind. He said, because in today's world, when you make something bigger, it draws more power, not less power. Now that's what this Granger catalog still shows on the conventional motors. All the way from a 1 horsepower, you can see that the amps, that's at 4 amps. as the horsepower gets bigger and bigger and bigger and bigger and bigger and bigger and bigger, all the way to 219 amps. Just like he said, they still build it that way. If that one draws 219 amps, the power broker said my motor should be highly inefficient when you build it strictly as a motor. Now what I'm going to show you people, so you'll totally know it'll change your world, is that we hook this to this in series and run it, and it's going to recharge these batteries. And so with that, we're going to let the machine speak for itself. So we're going to cut the film just for a second while we get it up to speed, and then we'll show it to you again. All right, now we got this machine running, and we got it pumping water at the same time. These batteries should already be dead by conventional wisdom. You're moving a 7,500 pound machine with a 1,750 pound rotary in it, hooked to a 375 pound mud pump. The only way this can happen is all of what you've seen with Garland Robinette and all the other scientists said that this is coming true. It tries to recharge these batteries on batteries that are not rechargeable. Let's hook in line this negative meter so you can see what I'm talking about. Now these meters have a device on it that if you hook it in line constantly, it'll cut off. That's why I'm taking it periodically, so that you can see exactly what's going on. I'll put this over on amps. See it going negative and positive. Negative and positive, 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 negative and positive. It's shooting energy back into those batteries. On batteries that are not supposed to be rechargeable. All right, we're taking it out of the line. And turn it off because it saves the batteries in it. We can take it anytime, you'll see the same results. Now you hook it to any other motor, and what you're going to see, it'll be on positive current, and it'll drain the battery down. It would already be dead. It's a no-brainer to every businessman out there. This machine is ready for mass production. It'll change the world. And running off these little tiny batteries. And it's recharging them at the same time.
What voltage are we running now?
All right, we'll check the voltage and see what we got. We got 308 to about 312 or something. It's changing all the time. Somewhere between 308 and 312 volts. And you see what the time is now, 1:18. We've been running for at least 4 minutes right now. 4 minutes. And those batteries should have been dead by any other motor. We can check the RPM. All right, now this is a digital readout meter. I have a piece of white tape on this shaft, and it'll read that RPM very exactly. I think that's 81. Isn't that 81?
Yeah.
That's 81 revolutions a minute. Now we'll check that every 15 minutes, and you will see it will not have slowed down very much at all, if any. Running this ABS pump. Now you can pull this ABS pump up on the computer and see it takes 10 horsepower to run this pump and shoot that water out like you see it shooting out. Let's check the voltage. going now from about 297 to 307. So it's fallen just a hair. Now keep in mind, discharging effect is taking place on batteries that are not supposed to be rechargeable. Turn this amp meter on. All right, you see it going negative, negative, and positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. And it's negative, 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 and it's positive, negative, 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 and it's positive, negative, 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 positive, negative, 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 positive, negative, 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 positive, negative, 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 negative. You can tell the negative is about 5 times as much as the positive. Now we can check the RPM again, and you won't see that it's hardly even changed. What was it a while ago, Mark? 81?
Yep.
Okay, now it's 80, so it's fell 1. All right, we've been a half an hour already. $296 is about the highest. The I think it's 289, but it changes so fast I can't read it. But we got it easy from 292 to, and let me check the RPM again. Do you want to see the current again at this time? You'll see it's doing the same thing. It does the same thing all the time. It's putting more power back into these batteries than comes from it. That's why it's running, because these batteries are ended up acting like a capacitor. That's why it keeps running off of this, holding that voltage up. You can see it go negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. But look how long it's on negative. 1, 2, 3. Negative 1, 2, 3, 4. Positive. Let me see that. 1, 2. Positive 1, 2. I can get 1, 2 on positive. All right, on negative 1, 2, 3, 4. Positive 1, 2. Positive. Let's see. 1, 2, 3. Occasionally I can get 3, but I can get 4 constantly on that negative part. $78. All right, we'll take a look at the current. You can see it. The negative's on a lot more than the positive on. The positive is when you see nothing. The negative is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now if you get on that white, it's 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. Now you won't see that on any other conventional motor. Disconnect it, take it out of the line. Now we'll check the voltage. .287 to 290. Long ago, these batteries should have been dead and the motor shouldn't have been running if the batteries had been trying to run the machine. They're not running it. I said, do you want me to check the RPM again? That's 75. Now we started off at 81. So in this hour's time, we fell 6 RPM in an hour with this load on it, using AA batteries. And the current's equivalent to what's in one little battery. We should have never been able to turn this motor over. We'll start with the voltage this time. .286 to about 277, I think. 286 to about 277. All right, now we'll check the current. And I'm certain we'll be seeing the same thing. And you see it going negative. A lot more than it does positive. And that can only be by that back charge going into that system on batteries that are not rechargeable. That's why they hold up like this. They only put that voltage in for a fraction of the time. That aligns the atoms in the mass. All the energy is coming from that mass. It is not coming from these batteries. That should be obvious to anyone. .74. All right, it's disconnected now. And the water's still running. The motor's still running. Any other motor that had this kind of a load on it would stop the very instant that you cut it off.